Today I'd like to do an example of an application problem involving rate equations and rate laws. So here's what you're given in the problem. You're given the actual reaction that we're dealing with, 2NO plus Br2 gives 2NOBr. And we're also given the rate equation, which is something that's found by experiment. Now remember, you're given both of these things as part of the reaction. So let's look at how we might answer some questions about that. The first one is, based on this information, can you say whether the reaction is one step or more than one step and why? Now, as I alluded to in the introduction section, is that when you've got a rate equation, you can see that the rate equation is what's going to tell you what's going on in the slow step. And we talked about that earlier. And the slow step is just going to involve NO. Actually, it's going to involve two NOs, NO plus NO, and that's the rate equation there. We'll get to that in a minute. But as you can see, the BR2 is nowhere involved in the slow step. Now, if the BR2 is not involved in the slow step, it must be involved in some other step at some other time, which immediately tells you that since the BR2 is not involved in the rate equation, that it must be more than one step. So we know we're going to have a number of things going on here in this reaction. We won't be able to explain it with just one step. Now when I say one step, I mean one step would just be 2NO plus Br2 gives 2NOBr, and that's it. But we know that that's not the case because Br2 is not involved here. So if the rate had been one step, reaction had been one step, what would the rate equation be? Well, it would have to involve everything that's in the reaction, which would be two NOs, that's why it's NO squared, and Br2 as well. So rate equals K NO squared Br2. That would be the entire sum of the rate equation right there, because it would involve everything, including the two NOs that's in here. So even NO and Br2 would not explain it. It'd have to be NO squared Br2. That's what it would be if it was one step. Well, let's get on here and see how we might actually come up with a plausible list of steps that would explain what was going on here. So what I like to do is this. I will first of all write out the actual reaction itself, and that's going to be 2NO plus Br2. Anything we come up with is going to have to add up to this initial reaction that we were given. Now here's what else we know. We've got the information in the rate equation. Rate equals K NO squared. So we know that NO plus NO gives something is going to be the slow step. Now here's why we know that. We know from what I was telling you earlier that the rate depends on what's going on in the slow step. The only things involved in the slow step are two molecules of NO, and we know it's two because of the the squared up here, so it's NO squared, which means that we must have two molecules of NO involved in the slow step. So it's NO plus NO gives something, and that's slow. Now we don't know what that something is. Now a good general tip here is if you can form one of your products using the slow step, then you should. But in this case, since there's Br here, I really don't have the option of doing that. So the NO plus NO is going to give something else. It really doesn't matter what this something else is. It's just got to make sense at some point. There's many different ways of answering this and coming out correct. What I'm going to do is I'm going to come out with something different from this, and it's going to be N2O2. So I'm saying that NO plus NO is giving N2O2. I'll show you some different possibilities in a little bit that might also fit for that. So now what we know is, since I don't see any N2O2 anywhere in this reaction, so we know it must cancel out. So I'm going to take this and react it down here. And you might say, well, react it with what? Well, there's something we haven't looked at yet, and that's the Br2. So we'll react it with Br2. And if we do that, we're going to come out with 2NOBr. And we know that since that step is slow, this one must be fast. So what we did here, in essence, was we added the two NOs together. We got a compound N2O2, and then we took that compound N2O2 and reacted with the Br2. Now you can see what I mean when I say that this happened in some sort of slow step, and then the Br2 was added in some kind of faster step down the line. Now I want you to see that the NO plus the NO, that gives you 2NO down here. the N2O2 cancels, and we're left with no N2O2 in the final reaction. The Br2 is down here, and then you've got your two NOBRs over here. So the rules that we use here is that every reaction must form a different product than what we started with. They all must be balanced for charge, and they all must be balanced for number of atoms, and everything must add up to what's here in the final reaction. And those are the conditions that we're using. All right, let me show you another possibility for this first step. And something this would also work. And that would be NO plus NO gives N2 plus O2. And make that slow. And then we can take, since there's no N2 and O2 anywhere in the final reaction, we know that those two could be brought down into the next step and reacted with the Br2, and that would give 2NO-Br as well. And when we add that together, when we add those two together, we're still going to end up again with the same thing. So this would end up down here, and again we would end up getting what we wanted out of that. And let me show you one that will not work out. And that would be, this is a common mistake that people make, and they say, well, okay, so we've got NO plus NO, and I will just make that into 2NO. Okay, well, the problem with that is that what you've done is you haven't changed anything. NO plus NO gives 2NO. That's just giving you NO plus NO, which is 2NO, is giving you two separate NO molecules. Now 2NO looks like this, NO and NO. Now N2O2, which is what we used the first time, looks like this. It's NO and N double bond O, both connected together. So that's actually a single molecule. And here is two separate molecules right here for the NO. So that's why NO plus NO gives 2NO would not be a valid way of solving this particular problem. But this is. And this will, remember, the whole aim of this is going to be able to come up with reactions where we first of all know what's going on in the slow step, and then we can figure out how they add together to give what goes on here as our final reaction.